Hello there! This is a tutorial in which we go into how we can build a dimension grid. In the previous tutorial we showed you how to use this dimensions grid tool which I created. So here you have the dimensions grid with squares, and here you have it with hexagons and triangles. So let's dive into the triangles first and the hexagons, because it's the more complex one. Making grids is quite easy in geometry nodes. So if we go into this node, here we have the hexagon pattern. That is a node group which is repeated. If we go into this one, we can see here how it's made. If we make a viewer node, viewer, and then see what certain things are doing in here. So we are taking the size. We go back, we have here the size. For this operation we multiply it by 3 to get the right radius. If we go in here and we take the size to get a correct hexagon, the translation to make the hexagons connect, you have to use this dimension, which is you multiply the size by 0.288675. Then let's see what happens. What we have here. You go into mesh mode. Here we have a line. So with this mesh line, we create an offset for every point. So I'm not sure if we can see it. Well, there are points here, and with the amount, we have plugged in the amount in the X and Y amount is the amount of hexagons that are created in the X and Y axis. So with set position, you will see that we offset this line. So we have a line with certain points, then we offset it. And we do that by the index. Then we wrap the index every 2. So every next index. Then multiply the vectors by the size again. Divided by 2 and then the y coordinate. So if we turn this off, you will see what happens. It will go into this direction. If we take out the index, nothing happens. So unmute. So that's what happens in the offset. And then we feed it into the instancer. So if we go in here, we have a circle, 6 sides, which is actually the hexagon. So this is the hexagon, and here we calculate the positions of the hexagon. Like this is the exact position that you need to connect the lines together. So I fill the hexagons with an n-gon. Then if we combine these things, you see here that we get this pattern. Here we have the amount 10 and 3. If you take them away, you see that they connect. This next operation, in the level above, we copy this whole thing. So with the same amount, so it will connect. So what we do here, we create another mesh line. Then do it. Yeah, we do it in the other axis. So this is the 8. Here we do it in the x-axis, and this is the y-axis. And we stack 2 actually on top of each other. So they will connect also to the next point. Then I realize the instances, and then I merge them. So it all becomes one. All the lines or the vertices are connected. Then I center all the geometry. So the whole thing is nicely in the middle. Then what I do is I extrude them slightly, or actually I extrude them by 0, all the individual faces, and then I scale them down. So to 0, as you can see here, and then you get the triangles. So it's actually not hard to make a triangle grid from the hexagons, because you just scale them and then these lines will appear. And then merge them again. So then if we don't merge them, we have a lot of vertices that are stacked up in here. And if we merge them together, then they will merge and it's a normal grid again. And then here we can switch between this hexagon pattern, as you can see here, and the triangle pattern. So you have that option. So let's delete this and we go a level higher. So this is the hexagon pattern creator. And then here, this is multiplied by 3 just to make the radius of the hexagon correct. Because here you set the radius of the hexagon to 1, and it's exactly 1 here. That's, you have to multiply it by 3. And then if we create here a viewer node, what we do here, we extrude the mesh, the hexagon mesh. And then we create another extrude on that one. And we combine them. So we extrude one way and the other way. So this is to the top and this is to the bottom. And then we combine them again. Then we have like a volume. And then we use that as a volume to calculate what's inside. And we need that because if we go here, we have another hexagon pattern over here, and it's bigger. And here we subdivide the hexagon pattern. So if we go in here, you see that it's now subdivided as triangles. If we go in here, you see that it, with every box, we subdivide it again. So in this way, we can create more and more triangles. And here we have a multi-gate, so you can switch with the index between how many subdivisions we want. And if we do a dual mesh, they turn into hexagons again. So this way we can also go higher in the, or lower in the subdivisions. You see we get bigger and bigger triangles. So this way you can subdivide your hexagon pattern. But if we go in here, let's connect this one, or actually don't go in here, it's just like we extrude, then we scale the elements and then merge them. Then we can also use the dual mesh for that. And then here you see, because for the first one we don't want to use a dual mesh, the second one we do want to use a dual mesh. So I can explain that also by making another one. Let's create a plane. Let's see, it's over here. Then we create a hexagon grid. No, just a simple hexagon pattern. Let me see. It needs a size. So here we have a hexagon pattern. We do a extrude individual to 0. This needs to be faces. Yes, so we extrude it. You see we extrude it. We want to extrude it 0. So like the faces are laying on top of each other, and then scale the elements. Scale them to 0. And then only the top faces. So if I drag this out, you see what happens. This is actually what happens. So we want the scale to go to 0. So we have a lot of vertices stacked here. And then we want this one also to 0. And then we merge these points back together. So we don't have stacked vertices. That makes a triangle pattern. And if we do a dual mesh, dual mesh over this, we get hexagon patterns again. And this way we can subdivide the hexagon pattern. So if I select all this and I mute it, you see that they get smaller. And I can make it like triangles or hexagons. So this is how this hexagon subdivision modifier group works. Go back into here, then go to our nodes. This is the hexagon subdivision. Here we choose between the different subdivisions and a dual mesh at the end, which we can switch between triangles and hexagons. And then what we do next is we delete some stuff. So we delete the outside of this volume. So we created this volume and a lot of geometry is outside, and we get this really ugly stuff here where it's all cramped up. And then by inside volume, it calculates what is inside the volume of the pattern that we created, and then we get a nice subdivision of the hexagon grid that we have here. And then what we do is make mesh to curves, then curves to mesh, and then it gets a thickness. If we look like this, select it, you see that we give the whole thing a thickness. So this way we can set the thickness of the grid. Go into this mode. Here you can see the grid. If we combine it with the other one, you see that we get because here we have the hexagons, here we have the triangles, we combine them, and then we get this subdivision over it. And then also I set the colors, so here you can choose the colors of the different materials. I use this background and grid colors that you set in the materials. So if we go to shading, here you have the background. It takes background as an attribute, plug the color. So these colors, this is the background color, it comes in here into your background shader, and this is for the grid, so it's called grid, and that's this color. So that is how the hexagon pattern works. And if we zoom out, delete this node and go back, here it's neatly set in all these parameters. For the hexagonal pattern, if we go into the node, it's fairly straightforward. Like here also you have the annotations, like how many inches or feet or centimeters or meters it is. So as you can see, if I toggle through, that comes in here. So it's actually just an index 1 to 4. I feed the index into my string multigate. And multigate is just like nodes that follow each other up. So index 1 takes string 1, index 2 and takes string 2. It's just with a greater than 1, greater than 2, greater than 3. Sends the right one through. So then easily you can toggle between all these strings. So if we go here, we made a dimension calculator and it goes in meters. So here you can see what it is. It's like we take the X and Y dimensions of the grid and then take value to string of the X and Y dimensions. And then also you can choose the decimals we plug in here, you can choose here, and then as you can see, if we take less or take more, we can see more decimals, and then it combines them into a string. Also we set here, set value is how we call the string. So what comes in the top here, the top line is 1 because it's set to 1 meter. Change this, you see that it gets a bigger value. Let's set it to 1 again, and then here we call it meter X, meter Y, which comes in value X, value Y, and then we combine them with a line break, so it's on top of each other, the X and Y values. If we go up here, you can see that if we multiply this by 100, we get centimeters. If we multiply this by 3.281, we get feet. We multiply 1 meter by 39.370, we get inches. Then here with the multicade, we toggle between these values. And then we create a string from it. And if we say viewer node, we can see what happens. We make a string from it. It's actually just this, just an outline. Fill that outline here to see what happens. So here it's an outline. Fill the outline with an n-gon, so it doesn't have extra geometry. It just fills it with a face. Then we set them to the grid. No, what happens here? Mesh to points. It happens here. We extrude it a little bit and then we set it to the grid. So setting it to the grid is what we did beforehand here. So where we take the x and y dimensions and then we multiply and subtract, add, subtract, then we get this grid. Here you see the grid that we have, then also the amount of vertices that's being calculated. I had to do it this way to get it to add squares and keep the distance of the squares the same. So the x and y come in and add and multiply the amount. Then if I add more squares, you see that the same distance of the squares or the dimensions of the squares stays the same. If I would have taken just a grid, if I take this one for example and I plug it in, you can see what happens. Like if I scale this up and I add vertices, it divides it, and that is not what I wanted. I wanted these dimensions to be the same for every square. So that's how I solved it with these add, subtract and multiply nodes. And then we did it again for the segments. Plug this in, you see that it makes segments. I did it by subtracting 1 from the segments, so separate segments indices. As you can see, it divides the squares that we already have by 5 by adding 1 and then multiplying it by the x amount and y amount. Then we add also here for the x amount. Then we plug it into the grid and we get the same thing as we have here, but then as a subdivision. Then I don't subdivide it, so this node does nothing. And here we go into separating the x and y. So if we go here, we delete the x. Here you see we only get the lines in the y dimension, and here we get the lines in the x dimension. And then we join them together again. And we need to do this, or else in the corners where all the vertices are connected, like we get weird things to happen. And then if we thicken up the lines, because now we give it a bit of thickness, as you can see here, no thickness, curve to mesh, we give it thickness by using a quad, and then we can thicken up our lines. Then we do that here, we join them together with the background. As you can see here, background is white so you don't see anything, and then set the material. Then you see that our grid has a thickness. If I then delete this node, here we go into, we do another viewer node. Here I do the same thing, thicken up the grid. As you can see here, it's this grid. Here we combine all the things. And then here the colors are not set yet, and here the colors are set. So you see we have the regular grid, we have these segments. If we give it more segments, it really divides this square. So you know how big they are. If this is 1 meter and you divide it by 10, for example, you have this division of 1 meter. So that makes it very clear in how to build this grid. And also if you put on an object here, you know how big it is. So that is how I build the hexagon grid and also the rectangular grid. And here you can see how I did it. So you can build it also yourself. And I hope this is useful for you. And yeah, there we go.